A railway track crosses over a bridge that has a span of 20 meters, which, by the way, we're just not going to use the 20. Okay. The bridge is subject to a periodic force as the train crosses. This is caused by the weight of the train acting through the wheels as they pass the center of the bridge. The wheels of the train are separated by 25 meters. Show that when the train, the speed of the train is 10 meters per second, the frequency of the periodic force is 0.4 hertz. Okay. Well, again, there's lots of ways to do this, right? The frequency ultimately is just going to be the velocity divided by the distance, right? Okay. So we could just go 10 meters per second is our velocity. The distance separating the wheels contacting the bridge is 25, right? More formally, I guess we could say, look, the period is going to be the distance divided by the velocity, right? Distance over velocity is time, right? Okay. And therefore the frequency will be 1 over the period, okay? But anyway, either way, you're going to, there it is, right? Okay, so let's see, 0.4 hertz, there we go. So just show that. Okay, then the next thing says, the graph shows the variation of the amplitude of vibration of the bridge with driving frequency D when the damping of the bridge system is small. Outline with reference to the curve why it is unsafe to drive a train across the bridge at 30 meters per second for this amount of damping. Well, first off, you got to figure out what this resonant frequency is. Okay, so figure out what that frequency is. Okay, then figure out what this frequency is here, right? So 30 meters per second, right? Now I'll give you a clue. If 10 meters per second is 0.4 hertz, 30 will be, there's a proportion there, right? You could do it that way. You can also just do it this way, right? The frequency will be whatever that velocity is over the distance, right? Okay. But anyway, there it is, right? Okay. And then here's that same question again, right? We like this question. The damping of the bridge system can be varied. Draw on the graph a second curve when the damping is larger, right? So remember, as you increase or decrease damping, these things happen. The width of the peak changes. Okay. So we got to change the width somehow, right? Okay, either narrower or broader. Okay, the height of the peak, and I'm talking about this little peaky peak right there. Height, GHT, height will change, right? Let's see, the width, it'll shift slightly to the right or left or right. So look that up, right? There's a change there, and then at the extremes, there's also something that's true. Okay? So there's 4 things really that we're looking for that. Okay, so I think you can do that. Just review your notes. I mean, I don't know what to do here. I could just draw it for you, but All right.